Video lesson 10.4. Today we're going to be talking about the circumference of a circle and also its related arc lengths. So just as a refresher, circumference represents the distance around the circle. It's essentially, we kind of think of it as the perimeter of a circle, but a perimeter, a circle not having any edges. So that is the distance around the circle itself. So we do have the formula here, which will important to know. You have C is equal to pi times D. Again, if you remember that little nursery rhyme, so to speak, like, cherry pie is delicious, apple pies are too, to help remember the difference between circumference and area of a circle. So C is equal to pi times D is kind of the norm. A lot of times at this level, we're dealing with circles that don't necessarily have diameter. So we more often have the radius. So a lot of times we utilize this version. We know that the radius times 2 would be equal to the diameter. So it's just simply a manipulation or an alternate form of that. Again, both of them will work. There's obviously nothing wrong with just, if you have a radius, just simply doubling it to do the diameter. Or if you have a diameter and you need a radius, just have it. So whatever the case might be, whichever version you like is fine. So dealing with the first example here, we've got x squared plus y squared is equal to 25. And as we discussed in the previous video, this is the equation of a circle. Right now, we're just focused on the fact that this is my r squared. So in this formula, we do need what r is because we only are using 2 pi r. So I can just kind of off to the side here say, well, r squared is equal to 25. To get r alone, we could take the square root of both sides. That's going to get me r to be 5. Once I now know that, I can now say, I can work backwards and say, okay, C is going to equal, my circumference is going to be 2 times pi times 5, which is what my radius is. This would be 10 pi. Again, this would be my answer in terms of pi. It doesn't tell me to round or anything, so I'm definitely going to leave it like that. That's an exact answer. But again, if it required me to round it off, I could always just plug that into the calculator and get a decimal equivalent. All right, example number 2. We've got a tree trunk that is roughly a circular cross section. So again, cross section is just if I took in this case, the tree trunk, if I just chopped it in half and split it open, what would the inside shape be? In this case, it would also be a circle. So a logger used a tape measure to estimate the circumference. The cross section is 6 feet. So they took a tape measure and went around the tree. So, right. Here. So we're going to say, in order for us to determine the diameter, we're going to say the circumference is equal to pi times, in this case we want the diameter, so I'm going to keep it as D. We know that the circumference is approximately 6 feet long. So the 6 is going to go in for C. But notice all of my answer choices are in terms of inches. So it would be best to say, well, 6 feet, right? That's equivalent to 72 inches, right? Because there's 12 feet in every foot. So if I multiply 6 by 12, I get 72. So I'm going to plug that in as a 72 rather than a 6. This way, when I solve, I don't have to do any conversions later on. Again, if you wanted to solve it in feet and then convert at the end, you'd be fine there too. All right, to get the diameter, we're going to get rid of the pi part. I'm going to divide by pi. So diameter is going to equal 72 divided by pi. And in this case, I do want to get an approximate answer here. So we're going to plug that into our calculator and get 22.918 blah, blah, blah. So that's approximately 23 inches, which is choice number 2. So that was like kind of a work backwards question. When they give us the circumference, we got to find the parts. All right, next one. You're given this diagram, which is a garden enclosed by a rectangle and a semicircle. They want to put a fence up around the outside edge, not across the dashed line, aka the perimeter of the figure. So how many feet of fencing would be needed? So we got to add up all the sides, right? We got to get this plus plus this would be the rectangular part. And then I want to add this semicircle portion to that. Well, good news is it's a rectangle, so opposite sides are equal. So this is also 17. So this red portion is easy. Just add 17 plus 12 plus 17. It's the circular portion that we have to find out first. So let's take off to the side here. Let's do that part first. So the circumference of that, again, it's not a whole circle. It's only half of it. So it's going to be half pi times the diameter. Right? We do know that the diameter is 12 because, again, this is a rectangle. So this is also 12. So I'm going to have 1/2 pi times 12. So that's 6 pi. Again, I'm going to leave this in terms of pi here until I plug it in and to the very, very end. I don't want to be carrying around decimals if I don't have to be. All right, so perimeter is going to equal, we said we're going to add up all three sides. So that's 12 plus 17 plus 17 plus the 6 pi that we just found. So if I add this all up, I get 46 plus 6 pi. Again, this is my answer in terms of pi. So if I was asked to, I could just stop right there, but they did take to round to the nearest foot, so I do want to actually calculate this. So if we plug that into the calculator, let's see what we get. We get 64.84955, blah, 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 blah. So nearest foot is aka nearest whole number, so that's approximately 65 feet of required fencing to fence in this figure. All right. So one other aspect of this is arc length, which is just a portion of a circumference. So in this case, they're saying, you know, what is the length of just this highlighted section, right? Now they tell me the degree, and a lot of times a lot of students want to say, well, it's 60 degrees, that's its length. It's not its length, it's just its degree measure. That 60 degrees represents this central angle here. So if I was to draw this back to the center of the circle, that 60 degrees is represented of this angle here, that central angle. They're equal to each other. I want to know how long would it actually be, length of this, like how many centimeters is this? If I was to actually walk this 60 degree arc here, how far have I gone? All right. Just like area of a sector, right? Area of a sector is just a portion of the area. Well, the arc length is just a portion of the circumference. So if we figure out what the entire circumference is, all I got to do is multiply by what fraction of that I'm talking about. So let's figure out the circumference first. So circumference in this case is equal to pi times, well, let's use 2 pi times r in this case because we have the radius. So we're going to have 2 pi times 10. So that's 20 pi. So again, that would be the entire circle's circumference all the way around. But I don't want all of it. I just want this red section here that I've colored in. So I'm going to take the circumference of 20 pi. So I'm going to take the 20 pi and I'm going to multiply it by what fraction, right? So 60 degrees, right? It's 60 degrees out of the whole thing, and there's 360 degrees in a circle. So if I simplify that, I can do, that's 1/6. So I can say 1/6 of 20 pi would be just this red portion here. So that would be the arc length. Right? So in this example, if I can say this is just over 1, right? So that's 20 pi over 6. I could take 2 out of each of them, so that's 10 pi over 3. That would be my answer. A lot of times this is left in terms of pi. Once again, if they ask me to round it, I just plug it into the calculator and find out what my value is going to be. So let's write ourselves a little formula here to kind of help us remember this, so I don't have to keep kind of doing each part off to the side. That can get a little annoying. So arc length is equal to, we're going to do arc degree And remember, the arc degree is the same as the central angle, so they can give me either one of those two, in the degree in either spot. So arc degree divided by 360, that represents the portion of the circle that we're talking about. And we're going to multiply that by the circumference. And again, I'm going to use the 2 pi r part because that's realistically a lot more common. You're going to have a radius rather than a diameter in these types of questions. So it's a little bit better to utilize and memorize it with the 2 pi r version. So that's your formula. All right, so again, it's a really easy thought. It's just simply what fraction of the circle am I talking about, and I'm going to multiply that by the entire circumference. But this is a formula I strongly recommend that you memorize, right? It makes things significantly easier and faster. It is very similar to the area of a sector one, so do be careful. There's very little things that are different between the two, but it's important because those differences are what make them unique. All right, one other thing that often comes to this is minor arcs and major arcs. So if you, it's very simple. Minor arcs are just arcs that are going to be from between 0 and 180. So really less than 180 degrees. And the major arcs are ones that are from 180 to 360. So again, just kind of think bigger than 180. So if I have a circle here, I'm just going to draw a quick sketch of a circle here, right? A major arc, right? And a minor arc. So if I just made an arc, let's say I went from here to here, right? That would be an arc, right? That's less than 180. So that would be the minor arc, right? The remaining portions, like all of this, would be the major arc. And the key to that is because let's say I called this A and this B. And I said to you, hey, I'm talking about arc AB. Do you know which one? Both of those are arc AB, right? The green part is an arc from A to B. The red part's an arc from A to B. So you have to make sure you distinguish between the two. The default is the minor arc. So if I said to you AB, I would be talking about the minor arc. If I wanted the major arc, I'd have to either say major arc AB, or what is often more common is we stick like another letter here. Let's say call it like C, for example. And then we'd say arc ACB, and we describe that like so. So the minor arc in this case we'll call AB, arc AB. The major arc would be ACB. But again, if I didn't have that letter, I'd have to physically write out the word major and then say arc AB. But again, we'll get into more detail with that in the next couple of days and units. But it's good to have in the back of your mind as you go. All right, let's do one more example of actually finding the arc length. So I want to know the distance from A to C. So again, in your minds, is this a major arc or a minor arc? It would be a minor arc because the whole circle, right? This is only a portion of it, and that portion is less than 180. So arc length, let's do here. So arc length is going to equal. So again, we got the arc degree over 360. We're going to multiply that by 2 pi r, which is the circumference of the whole circle. All right, so let's find these parts. So the arc degree, that's going to be here. So in this case, it's now in here. Again, I could also give it to you out here. So we're going to have that part. And my radius, they're telling me, is right here, is 6. So arc degree divided by 360. So I've got the 130 divided by 360 times 2 pi, and my radius in this example is 6. So let's simplify this whole thing up. 130 over 360, I can simplify that to just 13 over 36. We're going to multiply that by 2 pi 6, which is 12 pi. And if we put this over 1 and multiply, I get, what's that? That's 156 pi over 36. And I can simplify that by dividing each of them by 12. Which gets me 13 pi over 3. And again, in terms of pi, would be your answer like so. If they do, they do actually want you to do it into the nearest 10. Yes, so they actually want us to find this nearest tenth. So I'm going to, so if we plug that in, we get approximately 13.6 inches. And then notice this is not inches squared. This is not an area. It's just a circumference. It's just a linear length in this case from here. I'm sorry, not linear. Sorry, just a length. It's a curve. So that's your answer. So again, take the opportunity to review the video, go back over any questions that you might have trouble with, and utilize the practice problems for a better understanding.